Hello, it's Friday, getting kind of late here. It is the 2nd of October and we're going to start our lesson today. We're going to begin with several topics, but the first one is even and odd functions. Eventually, our lesson is going to take us to a situation that looks a lot like this. Very interesting forest, wouldn't you say? So we're going to see why that applies to our studies today in a little bit. So hang on to that image. We'll be back to it. Alright, sorry about that. My little stand is a little wobbly here. Alright. This idea of even and odd functions, please take notes and we will get those hopefully in your comp book. If you don't have your comp book, just bring them with you on Monday. The even and odd functions are ideas that you've already seen, so I'm just going to review them quickly and see how it applies to our trig graphs that we've been doing. So if we have a function like an old friend, we hardly have done any algebraic expressions together. That will change, but, oops, not y equals x squared, but x cubed. We'll do x squared next. Alright, if we have y equals x cubed, it looks like this. And I was wondering if I could represent y a different way. And I can. There's another way, and it'll be more helpful for this discussion. F of x. We can always replace y. And we could say f of x is x cubed. Let me get my timer going here. And we'll be back to the crooked trees here. Alright. When I was wondering if I'm looking at this function, I was wondering if this function, f of x, would be equal, so this is a question mark, to f of negative x. So I'm going to look at that, and the way I'm going to investigate that, I'm going to pick an x. So say I go out this far, stop, and I'll call that x. To find f of x, you go up from your x value till you hit the graph, and you want to see what its y value is, or its f of x value, and it's red over here. So you eyeball over here, and whatever value is sitting there is your f of x. Alright, now let's evaluate f of minus x. So this means the function evaluated at negative x. So I'm going to go out this way. Let's see if I can get it up there on the x-axis. So you can see so I'm going to go out, here was x, so I'm going to go out just as far as that, but in the other direction. So does that look about the same? So I'm going out from the origin, negative x. So then I'm going to go, to hit the function, I can't go up, I'll never hit it, so I'm going to go down. And I hit it right there, and I read its value over here. And that is f of minus x. Notice the value f of x and the value f of minus x are not equal. One is positive and one is negative. So there's no question about it anymore. These are not equal. But there is a quick adjustment I can make. Can you think of what it is? So that these two statements would be equal. Well, this value is positive, and this is the same value but negative. So what if I stuck a negative sign on one or the other? Then they would be equal. Negative f of x equals f of negative x. And whenever we have that situation, like we do with y equals x cubed, we say the function is odd. An odd function. Alright, so that's an odd function. And we will always look and see this kind of thing happening. F of x will be a certain number, and f of negative x will be the opposite number. All right, let's look at one that is not odd. So this is y equals x squared. It's the smiler. smiling always. And I was wondering if f of x in this case equals f of minus x. So to evaluate that, I go out x in this direction, hit the graph and read here, that's f of x. And when I go out minus x, look what happens. When I evaluate this function at minus x, I go up and I hit the same value. So this is f of x and it's also f of minus x. So in this case, they are equal. So when that happens, we say it's an even function. And this should jog some past pleasant memories, even in odd functions. The pictures are always similar. When a function is on this side, when this is going up, this is going down. Sort of the opposite thing is happening over here, and that's true for odd functions. Here, it's like a mirror image across this line. Whatever's happening over here, the same thing is happening over there. So, even and odd. So with that in mind, let's categorize the sine function and the cosine function. So if I have y equals sine x, it starts here and goes down. And we have to go across the origin, but you knew it went in this direction in the same way. So looking around here is where we check for even and odd. Is that an even or odd function? Well, as I go out x, and I check the function, I get this value, but I go out negative x, I get this value. So I'm showing you quickly, you can see it acts like this one up here. So we have an odd function. Specifically, we can say the sine of positive x, this is where I pictured it here, so this is f of x, or actually sine of x, because I'll actually put the function's name in. So that's sine of x. And if I go out this side, negative x, this is sine of negative x. So here, putting that in the terms of the sine function, we can say sine of x, I can't say they're equal just yet, because one is positive and one's negative, so we're going to have to put a negative sign in front of one side or the other. So minus sine of x equals sine of negative x. And that's actually just a reflection of thought that this is an odd function, but it is also a trig ID. So I think we're up to number 18. Let me know if that's not true, but I need you to add that to your trig ID page number 18. And you could call it number 18 right here in the middle of your notes as well. So let's go on to the cosine function. So looking at that, around the origin, that's where we're going to check for whether it's even or odd. So if we go out x, we hit this value, and that's f of cosine of x, and if this is negative x, this is the same value going back, minus x. Notice that value is here. So therefore, they're the same. So f of minus x and f of x are the same, which is a characteristic of an even function. So we can say cosine of x is the same as cosine of minus x. There's number 19. So that reflects the fact that cosine is an even function. All right, I went over that quickly because the idea of even and odd shouldn't be new. And we're going to learn a new function this evening, and the graph of a new function. And we will discuss whether it's even or odd once we get its picture. Let me turn over the back here so I can spread this out. The one we're going to graph is the tangent. So we're going to graph tangent y equals tangent x. And when we graph y equals tangent x, I'm going to remember the trig ID that tells me that tangent of x is sine x over cosine x. That's that one I star and emphasize a lot because it comes up so much. So here it is, true to form. So when that happens, whenever we write a graph tangent, I always think of this. And I notice that in the denominator is the cosine function. And we also know from our past math experience that the denominator cannot equal 0. We are not allowed to divide by 0. So therefore, let us look at the cosine curve before I graph the tangent. So I'm going to graph the cosine curve right here. It goes up to 1, down to -1, and my 4 tick marks, pi over 2, pi, 3 pi over 2, and 2 pi, and in the other direction I need to go as well. I think that'll be enough, those two, negative pi over 2 and negative pi. So if I was graphing cosine, remember it starts up pi and then comes down and returns up high. It's going to do the same thing over here. I just graphed half of it over there. So notice there are times when this cosine curve equals 0, and that's right here at pi, negative pi over 2, right here at pi over 2, and right here on 3 pi over 2. But I said that can't happen. So right under this, and I almost always pair these up, and right under this, I'm going to, wherever this one crosses 0, I'm going to line up this one right under it. And this becomes an asymptote. An asymptote is a point on the graph that this graph, a vertical asymptote is a point that this graph will never touch. So we don't divide by a value of 0. And I can put this one in as well if I want. This is 3 pi over 2. And these are going to keep going in like fashion. So there's pi over 2, there's a pi in between here, and this is 0, and we could keep going, but we won't. All right, that's plenty of them to get the idea. They go forever, these asymptotes. And if I go back to our unit circle to help us get some values maybe in here, so let's get some of them. Let's see. Instead of just spoon feeding you the graph, let's see if I can tease it out of you. So let's just do the monkey math. This is 1, 0. This is 0, 1. This is good. So and maybe this one right in the middle, pi over 4. You'll recall its value is square root of 2, square root of 2. So I'll put in pi over 4 right there. Alright, so pi over 4 is halfway between 0 and pi over 2. I'll put the tick mark there. So, what is this, the tangent? Since we're graphing the tangent curve, the tangent is this value divided by this one. 0 divided by 1, which is 0. So the tangent of 0 is 0. So that's a point on my tangent curve. When I go to pi over 4, which is right there, I divide this second value by the first and I get a 1. So I'll say 1 is up here. And when I get up to here, I end up taking 1 divided by 0, which is that impossibility. So it looks like it's just going to go up closer and closer to that curve because we can't ever divide by 0. So I'm getting closer and closer to the asymptote, but I'm not touching it. If I investigate this side, I would look down here, and this one is negative pi over 4. I could call this negative pi over 4, and its value is square root of 2 over 2 minus square root of 2 over 2. And when I divide the second by the first, I get negative 1. So pi over 4 graphs as negative 1, and without doing it anymore, I'm just going to go like that. So this is repeated all the way as far as you want to go. And I think God